Welcome everybody to a new video about the topic of surfactant. Well, first off, what is surfactant and where is the surfactant produced? As you can see here, the surfactant plays a very important role in the alveolus, which is the smallest functional component of the lungs. And why is surfactant so important? Upon exhalation, when there's no surfactant present, the alveolus has the ability to collapse, which you of course do not want, because if all of our alveoli collapse, we are not able to breathe anymore and to have diffusion that occurs here. So the O2 and the CO2 cannot diffuse, and that will be will have very bad consequences. So where is the surfactant produced? Well, the surfactant is produced in the alveolar epithelial cells type 2, which you can see here. And these will produce the surfactant, and the surfactant will reduce the surface tension in order to, when we exhale, that the alveolus does not collapse anymore. Okay, so what is the composition and the function of the surfactant? Well, the composition, as you can see here, surfactant is composed of about 90% of phospholipids and about 10% of proteins. Well, the 90% of phospholipids are very important because the phospholipids are the main components that are responsible for the reduction of the surface tension. And this is also the main variable that allows the surface tension to be reduced, and that allows the alveoli to not collapse under when exhaling. Then we also have 10% of proteins, and these 10% of proteins also play an important role to two different kind of extents. We have these proteins can be classified in two different classes. We have the hydrophobic proteins, which are the surfactant proteins B and surfactant protein C. Well, these hydrophobic, as you can see here, the hydrophobic surfactant proteins, they stabilize the phospholipids. So by stabilizing the phospholipids, they also play a very important role and reducing the surface tension. So the hydrophobic surfactant proteins are more a kind of assistant proteins that help the phospholipids. Well, we also have another class, which is the hydrophilic surfactant proteins, which are classified as surfactant proteins A and surfactant proteins D, and these they have another role that they play, and this is the hydrophilic surfactant proteins are very important in immune functions, and they are derived from the collectin family. And you might wonder yourself, like, why are they very important for the immune functions? Well, I'll show you here. I'll move this across. Well, so how do the surfactant proteins A and D recognize foreign intruders, and so therefore play a very important role in the immune functions? Well, this is how such a surfactant protein A or D looks like, so a hydrophilic one. So you have here the N-terminus, and then you have a collagen part, a neck part, and this is the main part that's very important, which is the carbohydrate recognition part, which is on the C-terminus. And what this carbohydrate recognition part does, it will bind to any foreign intruders that have a carbohydrate group or component, which is very important because most viruses, so viral intruders or bacteria or fungi, they have a carbohydrate component to which this carbohydrate recognition part will recognize it and bind to it, and therefore they play a very important role in recognizing these foreign intruders. Then we can move on to the synthesis, secretion, and the recycling of the surfactant. Well, of course, the surfactant needs to be produced and has a life cycle within the alveolus. So that's what this part will be about. So as you can see here, we have the alveolus, and these are the alveolar epithelial cells type 2, and these are the type 1. And what you can see here, this is a kind of enhanced picture of enhanced part of the cell type 2. And what you can see here is that normally when we just eat like normal, we have dietary substrates, and these dietary substrates are used within this alveolar epithelial cell type 2 to produce surfactant. Well, the substrates are taken up by the type 2 alveolar cell. Here within the endoplasmatic reticulum, surfactant is produced. Then the surfactant will be modified within the Golgi apparatus and the Golgi apparatus. Then from the Golgi apparatus, all of these parts, the surfactant and the proteins, will be collected within a lamellar body, which is a kind of collection structure that collects all of these parts. And then the lamellar body will eventually be exocytosed into the alveolus here, with all the components still present. Well, then eventually it will migrate, and then we have a tubular myelin. So it's a kind of lattice-like structure here, as you can see by the form. And this tubular myelin will then eventually migrate to the air-liquid interface, which we will show in a minute, where the phospholipids will play a very important part in reducing the surface tension. Then, of course, also you have the surfactant proteins, and the surfactant proteins, like mentioned earlier, play a very important role in either stabilizing these phospholipids, or playing a very important role in the immune functions. Then after reducing the surface tension, we of course also need to be degraded or reused again. So these phospholipids can then be taken up by another lamellar body that is destined to be degraded by means of alveolar macrophage that will take them up and degrade them. Or these phospholipids can be reused, so they are reuptaken by the alveolar epithelial cell type 2, where they will be used again for the production of surfactant. Well, like here in the picture, it's kind of difficult to see because the air-liquid interface is not present here, but it is here, which have the air-liquid interface. And so you might wonder, well, how does it exactly reduce the surface tension? Well, like here, you can see here you have the cells, and then this is the alveolus immediately. But in reality, what happens is that you have the cell types, and then you have a layer of water molecules, of H2O. And this H2O is the reason why the alveoli have the ability to collapse. Since alveoli are very small structures, there's also not a lot of surface tension needed in order for them to collapse when exhaling. So therefore, this is the air-liquid interface. So these a synonym for the alveolar epithelial cell type 2 is a pneumocyte, and this will secrete these lamellar bodies, which eventually help with the surfactants, so the phospholipids here. And these phospholipids have, of course, a hydrophilic and a hydrophobic side, since they're phospholipids. So the hydrophilic side will have its head towards the liquid part, so towards the water, and the hydrophobic part will then have its part here, and this will reduce the surface tension, which is a kind of the attraction that water molecules innately have, and thereby reducing the surface tension, and this leads to the alveolus being able to stay intact, so not collapse when exhaling. So it is essentially really easy, but to get to know all the components that are present here is kind of difficult sometimes. Well, then we have had the whole life cycle and how the surfactant is produced, how it is used to reduce the surface tension, and then also how it's either reuptake happens, or we have degradation that occurs. But there are also some complications that occur. This is oftentimes due to preterm birth. And what can happen then is effects of preterm birth. Well, what is exactly is preterm birth? Well, this is a baby that's born before 37 weeks of gestation. And this is also when the lung development is not properly finished yet. So therefore, this can cause neonatal respiratory distress syndrome, as you can see here, which is abbreviated as NRDS. And what this neonatal respiratory distress syndrome is it is essentially that your alveolar type 2 cells have not properly matured yet, so the surfactant production is very minimal, and this leads to an insufficient amount of surfactant. And the surfactant, like mentioned earlier, is very essential in reducing the surface tension so that the alveoli do not collapse. So therefore, as doctors, they need to they need to treat this because it's very dangerous. So therefore it's treated either by one of two ways. We need synthetic surfactant that is sprayed into the lungs, of the child, so that there is surfactant that is present that can take over the function of the surfactant that is not produced by the child itself. And oftentimes this is mixed together with mechanical ventilation with positive pressure. So these are like these big cabins that you see that a child is in order to have mechanical ventilation, because the child is not able to breathe from itself because of the alveoli collapsing. But what this does is the mechanical ventilation. It produces scarring tissue on your alveoli and on your lungs. And this has the ability to eventually lead to bronchopulmonary dysplasia, which is that due to scarring tissue, your alveoli that you already have and those ones that need to be matured yet and still need to be produced are not good enough, so you are not able to properly breathe. So this is a very big problem that you can have as a child and eventually also later in life. That is oftentimes a mixture of the mechanical ventilation together with the neonatal respiratory distress syndrome, which makes it very important for children to be on term and not preterm, because that brings a large factor of complications with it. Well, this essentially is everything you need to know about the surfactant and how it is produced, what it does, and also the effects what an insufficient amount of surfactant can have. So if you've enjoyed this video, thank you for watching, and don't forget to leave a like and subscribe.